Hi guys, and welcome to week 7. So in this week, typical week again. Once again, Wednesday discussion board Wednesday, homework Sunday, and I should cross this out. There's no quiz this week since we had one last week. Again, big ticket is posted and is due on the 22nd. See the week 4 start here video, and this is the week in which you can start taking the midterm exam on October 5th, and the last day to take it is October 12th. Please see the midterm exam prep material posted in Canvas in the week 7 module to get more information on this and know exactly how to prepare, what to bring, all that good stuff. So I'll just let you read that, and make sure you read that very, very carefully so that you plan accordingly up front, and you make sure that you find a time in which they're open, that you come, and that you don't do everything last minute. So just pay attention to that. So this week, in terms of content, discussion board, market competition is a game. Is that possible? That's what you'll be exploring, as well as the binomial distribution. So this week's content will be on the midterm, but you're certainly welcome to get this cut out since this module week 7 is posted during the week 6 weekend. If you want to get ahead and get this done early, I encourage you to. Otherwise, you have until the 12th to complete it. So finally, I will go ahead and wrap up the discussion board. What if I retest? So here's the problem we were facing, and we knew that 1.8% of the population is known to have hepatitis C, and that we have a test that's 99% accurate. So given the setup, we want to know how likely is it that a person has it if they've just been given a positive test result. Now, it's tempting to say 99% because the test is 99% accurate, but we've got to think about the definition of accuracy. Accuracy means the ability the test has to detect the condition if it's there. So if I have 100 petri dishes, I would expect that, and all 100 petri dishes had the strain of hepatitis C in it, and I put the test and tested to see whether my test is accurate, the test would come back positive for 99 of the petri dishes, and one of them it would fail to detect it. So that's the test's ability to detect it. But our question is, we don't know whether or not you have it. We knew that those 100 petri dishes had it. We know that you got a positive test result, and we want to see how likely is it that you have the condition. We're going to see that's not 99%. So let's see how the 99% does come into play. So first off, if I assume 100,000 patients have it, that means, we are considering or studying 100,000 patients. That means 1.8% of 100,000 is 1,800 people. We would consider in that random sample of 100,000 people. 1,800 we would expect to have it. Well, the difference between 100,000 and the 1,800 is how many people don't have it. So very few people actually have it. Finally, or next, we would want to ask the question, well, of the 1,800, how many do we expect to get a positive test result? Since the test is 99% accurate, 99% of the 1,800, or 1,782 people, would receive a positive test result. Similarly, of the 98,200 who would be tested, 99% of them we would expect to get a negative test result. So yeah, there's a 1% of these two groups, the 1,800 and the 98,200, will unfortunately get the wrong test result. That is what we consider where the inaccuracy comes into play. No test is perfect. Okay, so next we can figure out if 1,782 of the 1,800 are going to get positive test results, that means that 18 people are erroneously going to get a negative test result even though they actually have it. Since 97,218 people of the 98,200 are going to get a negative test result back, that means 982 of them who actually don't have the condition, the test is going to say that it's going to come back positive. It's going to make those people think they do have it. Okay, well, next we can fill in how many people of the 100,000 are going to get positives and how many of the 100,000 are going to get negatives. Well, we can do the math here. We can add up 1,782 that got positives, the 982 that got positives. 2,764 people of the 100,000 people are going to get positive test results. Take the difference between these two numbers, and we get 97,236 in the population are going to get a negative test result. Well, we should expect that number to be really large, right? Because the condition is very rare and the test is pretty accurate. So most of the 100,000 people are probably going to get negative test results, with the exception of these 2,764 people. All right, well, if I want to ask the question, if I get a positive test result, or if a person has a positive, or out of the people who have positives, how many people actually have it? Well, 1,782 of the people who got positives actually have it, and 2,764 people in total got a positive test result. Well, 1,782 out of 2,764 is 64%. So that means of the people who got a positive test result, only 64% actually have it. That's startlingly low, which means, as we would normally expect a doctor to say, you need to get retested. Okay, well now we've got to think about who's going to retest and retest those people. So we want to ask the question of the people who got positive test results, which is all of these people in this column, we're going to retest all of those people right there. So that means that these numbers are going to be our new totals. Notice how it's no longer the case that 1.8% of these people actually have it. We actually know of the people who got a positive how many have HCV and how many don't. So we don't need to figure that out again. We have that information here. So we actually see that the number of people out of the 2,764 who actually have it is a little bit higher now. And so now we can do the same type of math, figure out 99% of that number, get that number. Figure out 99% of 982, that gives us that number. Do a little bit of subtraction, get that number, that number, that number, and that number. And now if we divide out of the people who got positive test results, 1,764 out of 1,764, sorry, I'm writing with my mouse here, out of 1,774, that's the number of people who get, of the people who test positive twice, 1,764 of them actually have it, which is about 99.4%. So if you retest, there's a pretty good chance that if you get 2 positive test results that you actually have the condition. Notice that it jumped from 64% all the way up to 99.4%. So hopefully that's been kind of an interesting problem to look at. You can do this for any possible test out there. If you can figure out, number one, what percentage of people actually have the condition, number two, how accurate the test is, which, by the way, normally there's an accuracy for positives and an accuracy for negatives. We just assumed it was 99% for both. So those are called specificity and sensitivity of the test. So we could establish those numbers and kind of get a ballpark of what the likelihood is that we actually have a condition, given that we get a positive test result back. Also keep in mind that, of course, these factors we assume that this 100,000 people, this is a random group, but certain things could predispose you to actually being more likely to have a certain condition than other things. I feel like I sound like an ad for medication, but in any case, that is true. So this gives us kind of a holistic sense of an entire group of people, but keep in mind that certain people might be predisposed to a condition. They might have a higher likelihood of having it just based on genetics and stuff like that. I don't know that HCV is one of those necessarily. It might be, I don't know, I haven't studied HCV, but keep that in mind as well. So hopefully this has been helpful. Again, focus on getting prepared for that midterm, and if you have any questions, let me know. Have a great week 7.